Is the screen visible to you? Screen visible to you? All of you? Okay. So, uh, yesterday we have finished up with the representation of particle size and all the things. Now today we will start with the derived properties of powders. The practical based on that we have already taken. So these are the several derived properties. It includes porosity, packing arrangement, densities, flow properties, bulkiness. These derived properties of the powder is going to be applied in different stages of product development, so that it may be tablet formulation, capsule formulation, suspension, likewise, or divided powders, powder in bulk, likewise, granule making. Likewise, all these properties are helping us in one or more of our operations. So, first one is the porosity. The term porosity is used to define the number of small spaces or voids present within a solid material. Suppose a non-porous powder is placed in a graduated cylinder, the total volume occupied is known as the bulk volume, VB. True volume is volume of powder. Means assuming that we are pouring the powder in the graduated cylinder. Graduation means those which are having marking into the graduated cylinder. Then whatever the volume that will get occupied by the powder, that will be a bulk volume, VB, true volume. Bulk volume is equal to true volume plus volume of spaces between particles, also called as voids or void volume. It is so obvious that when we place the powder into the measuring cylinder, along with the particle, there will definitely contain with some spaces in between these two particles or every two particles. So that spaces are called as voids. There is a volume of space between particle. So void volume we can also calculate, as you can see in the diagram. Void volume is equal to bulk volume minus true volume. What is true volume? Actual space or volume occupied by particles only. That is called the true volume. And what is bulk volume? It is a total volume occupied by the actual particles as well as spaces in between the particle. Totally it would call as bulk volume. And from that we can calculate the void volume also by subtracting true volume from bulk volume. V is equal to VB minus VP. So this is a small and essential term and comparatively easier terms which are a part of derived properties of powder. Porosity or voids epsilon of powder is defined as the void volume to bulk volume. Porosity E is equal to VB minus VP upon VB, or E is equal to 1 minus VP upon Vp. Generally, porosity is expressed in percentage, that is E into 100. Now, types of porosity. Intra-particle porosity. Intra means inside the particle. Intra-particle porosity, space within a single large particle. It may be a crevices in the particle. It may be a gap inside the particle. It may be a hole inside the particle. Shallowness inside the particle. Deepness inside the particle. All these are the intra-particle porosity. Percent epsilon is equal to 1 minus Sg upon rho into 100. Sorry, rho g upon rho into 100, where rho g is the granular density and rho is the true density. Next one is the interparticle porosity. Interparticle porosity. Space between two or more than two particles. So, whatever we have seen in the diagram, that would be your interparticle porosity. Percent E is equal to 1 minus rho B upon rho into 100, where rho B is equal to bulk density and rho is a true density. True density means it is a density of the actual particles only. Okay? Have you got the understanding of this properly? Now next one is the packing arrangement in powder bed. Now one more point, it might came in your mind that why we need to study this, all these small things. So let me tell you that when a powder is flowing from the hopper up to the turret or die cavity, the powder gets flown and it would get arranged itself in a particular manner. And the manner of that particle, arrangement of the particle, it will base on all these derived properties of powder. So that when we are manufacturing a tablet or capsule, always as a pharmacist, as a formulator, we are conducting or we need to conduct several pre-formulation studies. These are the study to be conducted before going for the main formulation. Before going for the main formulation, we need to conduct several small studies onto all the ingredients that we are taking, and that is called the pre-formulation studies. It may come in the third year. When the particles are uniform size of sphere, now packing arrangement we want to see. When the particles are of uniform size of sphere, they can be packed by any one of the following packing arrangement. Closest or rhombohedral packing, loosest or cubic packing. As you can see from the diagram, closest packing or loosest packing. So these may be the arrangement that may occur during the packing of spherical particles. Because based on the packing only, we can consider or we can calculate what will be the bulk volume a die cavity can accommodate. So that is the, so that depending upon that, we can consider the how much amount of pressure we need to add, we need to apply onto that bulk powder contained in die cavity, so that This becomes highly important to know the bulk volume, tap volume, and all these things. Porosity, theoretical 26%, in closest packing, and practically it is 30%. In loosest packing, porosity is much more, theoretically also and practically also. So loosest packing, it may happen depending upon the geometry of the particle, surface of the particle, so that we need to consider the things, all the things every time. The theoretical porosity of the powder of uniform sphere is, in closest packing is 26% and in loose it is 48%. Generally the particles of powder are between 30 to 50% porosities. If the particles, so this is the second example they have given. Now next comes after the porosity is the densities of the particle. Density. Density is defined as mass per unit volume. It provides characterization of flowability of the powders. As we know, anybody can assume that more denser will be the particle, more rapidly it will flow towards the bottom. As we know that during the tablet manufacturing, we need to consider the flow. We need to consider the flow from the hopper, flow of powder from the hopper up to the die cavity, and this flow is getting governed by the by the influence of gravity only. There is no such other external pump or pressurized equipment we can add in this operation. And as we know, the density of the particle only will govern this flow rate. So that we need to consider the densities, different densities. There are three types of densities: true density, bulk density, granular density. True density is the density of the material itself, excluding the voids and intra-particle pores. Means from the true word until now, you can easily guess that true is always being associated with actual particles only, excluding voids, interparticulate and intraparticle. Both the voids, avoiding both the voids, we can get the true density, true porosity, basically true things. True things is been associated with the particle itself and not consider the voids. True density or absolute density is defined as the, another word, absolute density is defined as the ratio of the weight of the powder to the volume of the powder. Very easy. True density is equal to weight of the powder upon true volume of the powder. True volume is equal to bulk volume minus void volume. In this way, you can calculate the true volume. Two methods are used to determine the true density of the powder as follows. One is gas helium displacement method, liquid displacement method. Okay. In the last lecture, I have discussed working of counter. In that, you have seen that electrolytes is getting displaced in accordance with the volume occupied by a particle. So these similar kind of phenomena is also occurring in these methods, and these methods are used to find out the density of the, or rather true density of the powder. So first one is the gas displacement method. In this method, gas pycnometry is used. This is also known as Picnometer. Picnometer. Hello, am I audible to you? Hello. Okay. Let me share the screen. It might have gone. Gas displacement method now. In this method, gas picnometer is used, also called as helium picnometer. Helium or nitrogen gas is used because it does not adsorb on solid samples and also get penetrate into smallest pore. So these are the very important characteristics shown by helium or nitrogen gas. It does not get adsorbed. At the same time, it can penetrate into each crevices or pores, intraparticulate voids and interparticulate voids getting penetrated by this helium or nitrogen. So this is the assembly of helium picnometer. Pressure detector is there. You can see the diagram. Sample cell, atmosphere, wall, vacuum, and variable volume piston. So these are assembly for the helium picnometer. Methodology, what to be done? Volume of empty picnometer is measured. Air in sample cell is removed by vacuum. Helium gas is introduced through wall. Pressure is adjusted with movable piston. A reading on the scale U1 represent volume of the empty cell. So first, in that picnometer, we have to place the gas and then adjust the required pressure. Second, picnometer is calibrated by plotting known sample of known true volume. We see stainless steel sphere in sample cell here. Sample cell air in sample cell is removed and sealed. Some amount of helium gas is introduced and further pressure is adjusted. A reading on the scale U2 is measured now. The difference between U1 and U2 volume occupied by the sphere. Third step, volume of sample is determined by stainless steel sphere is determined. The stainless steel sphere is replaced by test sample powder. After that, follow the procedure of above step. Reading scale US is measured. The difference between U1 and U3 volume occupied by the sample, it has been calculated by this equation. Next one is the liquid displacement method. In this method, solvent used are ethyl alcohol, water, mercury, etc. Picnometer or specific gravity bottle is used. Regular gravity bottle to be used. It is used to determine the true density of non-porous powder. A solvent in which the powder is insoluble is used. True density can be calculated by using the following formula. W2 minus W1 upon W4 minus W2. It is the ratio of the weight of the material to the weight of the liquid that is displaced. W1 weight of the specific gravity bottle, W2 weight of the bottle plus sample, W3 weight of the sample, means it will get by subtracting W1 minus W2 from W2, and W4 is the weight of the bottle plus sample plus liquid solvent. So these are the various equation and method that we can use for the true density. Next one is the bulk density. Bulk density is the ratio of the mass powder to the bulk volume. It can be expressed as mass of the powder upon bulk volume. Bulk volume is equal to is initial unsettled volume or pi r square h, where r is radius of measuring cylinder, height of the powder, and pi constant 3.14. So this bulk volume you have already seen done in our practical that we have conducted earlier when we call you in the lab earlier. Some particles are loosely packed, due to which a large number of gaps are present between the particles to the bulk volume. So the bulk volume enhances and the powder becomes light. It's a bulk volume. Depending upon the bulk volume, powders may be divided into two types. Light powder, the powders have high bulk volume or low bulk density. Heavy powders, these powders have low bulk volume or high bulk density. Smaller particles shift between the larger particles to fill the gaps, leading to dense or heavy powders. So basically, depending upon the particle size and its shape, uh, the arrangement of the particle will be occur. Okay. Then measurement of bulk density, that also you have done. It can be calculated by using graduated cylinder. Weigh accurately 5 gram of the powder blend. Transfer it to 100 ml graduated cylinder. Carefully label the powder blend without compacting. Now note the unsettled apparent volume, that is VB, that is bulk volume. Calculate the bulk density in gram per ml by using the formula mass of powder upon bulk volume. Now granular density. Granular density, it is the ratio of mass of the granules to the volume of the granules. The thing that you have done for the powder, that is to be needed to be done for the granules. It is determined by using the liquid displacement method. Granular volume is the molecular weight, is the mercury weight displaced by the granules in picnometer. So it is somewhat difficult to calculate the true volume or true density only, but it is very easy to calculate the bulk of all the bulk volume or bulk density. Bulkiness, bulkiness is the specific bulk volume, that is the bulk volume of 1 gram of powder. When we consider the powder accurately weighed 1 gram, then whatever the bulk volume you will get, that would be considered as bulkiness. Its unit is cubic per gram, cubic gram you can say. It is the reciprocal of bulk density, gram per cubic centimeter or cubic centimeter per gram. So whatever the volume, cubic centimeter means volume. Whatever the volume, that will come for 1 gram in simple. Bulkiness is equal to 1 upon bulk density is equal to 1 upon mass of powder upon bulk volume, that is equal to 1 upon rho B. Bulkiness increases with decrease in particle size. In pharmaceutical industry, it is important as the size of container for powder packing depends upon it. So if the bulkiness will be much more, what we need? We need much more bigger container as compared to smaller container when we consider the heavy powder. Okay, so understood what is my bulk density, true density, all the thing. Everybody understood? This we have already done, huh? It is easier so that I have gone very quickly, and there is no different difficult or different thing that is needed to be elaborated than what has been quoted. Now next one is the flow properties of powder. This also we have done. Flow properties of powder are the specific bulk characteristics. Some important flow properties of powder are as follows: compressibility index, Hausner ratio, angle of repose, dispersibility, etc. So flow properties basically flow properties are essential while manufacturing the tablet and capsule, because here the powder will get flown from hopper up to the dye cavity or filling station in case of capsule. They are affected by changes in particle size, density, shape, electrostatic charge, and adsorb moisture which may arise from processing and formulation. Powders may be free flowing or cohesive, that is sticky. So first one is the Kars index. Kars index, compressibility index, and Hausner ratio. The compressibility index and Hausner ratio can be evaluated by using bulk density and tap density value as follows. Now everybody knows the tap density, what is my tap density, and bulk density we have already done in practical. So from that easily we can calculate the compressibility index. Tap density minus bulk density upon tap density multiplied by 100. Hausner ratio, it also can be calculated, tap density upon bulk density. These are the scale of flowability. Compressibility index, so both the things have been given considering the formula. Flow characters, the powder which are having, which we can say excellent flow from the hopper into the dye cavity, its compressibility index is less than or equal to 10, and that is called the excellent powder in terms of flow, whereas its Hausner ratio would be 1 to 1.11. Similarly, if you can see poor flow powder, poorly flowable powder, its compressibility index would be greater than 38 and Hausner ratio would be greater than 1.60. And similarly, excellent, good, fair, passable, poor, and very poor powder can be recognized from these values. And basically these values can be calculated from simple tap volume, bulk volume, or tap density, bulk density. Very easy to understand. Tap density, it is the ratio of mass of the powder to the tap volume. It is obtained, that we have done already in practical by using tap density apparatus. It is obtained by mechanically tapping a graduated measuring cylinder containing the powder sample. It can be calculated by tap density is equal to mass of powder upon tap volume. म्हणजे समजा 1 ग्राम नाही 10 ग्राम जर का पावडर घेतला, मेजरिंग सिलेंडर टाकला, वे केलेला तर 10 ग्राम आपल्याला मिळाला. नंतर त्याच पावडरला टॅप केलं. टॅप केल्यानंतर जो व्हॉल्यूम कमी झालेला व्हॉल्यूम असेल तो व्हॉल्यूम नोट डाऊन करायचा, अँड देन यू कॅन प्लेस द व्हॅल्यूज इन द इक्वेशन mass of powder upon tap volume of the powder. So this is called the tap density. Dispersibility, next one. After density, it is dispersibility. Or dustiness or floodability. Dispersibility. What is happening when during the manufacturing of tablet, or the capsule, it is getting done in a particular area, a small room, that is called the area. It is contained with a tablet punching machine, and operators will be there. So what is happening during the processing, during the tablet processing, too much dust come out from the tablet while from in that area while manufacturing a tablet. Too much dust. So that what additional equipment needed to be incorporated, it is the dust collector. It is having a sensitivity, dust collector. Okay, so all the dust is getting collected from that area, so that it should not affect the operator. And but basically, the more or less quantity of dust that may get generated in that area, that is basically depend upon the dispersibility of the powder. If powder would be more dispersible, then obviously dust would be more. It indicates the ability of the powder material to flow or pour over a plane. Dispersibility apparatus is used to determine the dispersibility. Loss of material while dropping on to watch glass through the cylinder indicates the dispersion has occurred. Mathematically, dispersibility in terms of percentage, it is weight of powder in watch glass अपॉन इनिशियल वेट ऑफ द सैंपल. हम सिंपल एक्सपेरिमेंट करना है, ऊपर से पाउडर हमको वॉच ग्लास पे डालना है और फिर देखना है कि उस पाउडर का वेट कितना है. वो हम आसानी से निकाल सकते हैं. वॉच ग्लास का इनिशियल वेट एंड देन वॉच ग्लास वेट प्लस वेट ऑफ द पाउडर टोटल में से आप वॉच ग्लास का माइनस कर दोगे तो आपको पाउडर का वेट मिल जाएगा. और हमको ये भी पता है कि इनिशियल वेट क्या था. तो weight of the powder in watch glass upon initial weight of the sample into 100, that would be dispersibility. So here this is the assembly by which we can do the experiment. This is a drop point from a particular hollow cylinder so that the powder should go properly into the watch glass. Very simple assembly and experiment is there. Next one is the angle of repose. That also we have done in the practical. Angle of repose is the maximum angle possible between the surface of the pile of the powder and horizontal plane. That we have done. It was determined by using funnel method. Mathematically, it can be expressed as tan theta is equal to h upon r, or theta is equal to tan inverse of h upon r. We have done these experiments. Everyone, have you done that in our lab? Okay. So you can understand it very well. Where h is the height of the pile, r is the base of the pile, and theta is the angle of repose. So actually you have done, so I am not repeating the methodology. The formula that we can use is theta, tan inverse of h upon r, height upon radius of a circle that we are getting in. So this is the assembly. Lab jack for lifting up and down द पाउडर. हमने क्या किया था, हमने जो ऊपर की फनेल है उसको कम ज्यादा किया था ताकि फनेल कांस्टेंट रहे और आपका जो पाउडर का जो हॉरिजॉन्टल सरफेस है वो ऊपर नीचे हो जाए. When the angle would be, and to increase the flowability, what do we need to do? We need to increase the particle size, coarseness of the particle, coarseness of the powder. And because fineness will promote the less flowability. Fine will be the powder, less flowable the powder will be. So these are the angle of repose. Now factors affecting the flow properties of powder are factors that can improve powder flowability. This also we have studied in the suspension. Attention. Hello. Okay, but the screen sharing lost, no? Hmm. Flow activators, the agents which can increase the flow. And the example I have already been given, glidants. Basically, these glidants and lubricants are stearates, magnesium stearate, and all these things are the examples of flow activators which can increase the powder flow. Okay? So this is all about the flow properties learned in our practical also, in our regular lectures also. Several times we have discussed. So basically, all these about the micromeritics. So any doubts about this? If you can have, then you can place it into the WhatsApp group. Some of the students, especially from the uh, second year DPharm, are regularly placing me the questions onto my WhatsApp group name, WhatsApp, personal WhatsApp, and I am giving the answers to them. Okay, and they are getting satisfied. Okay, but a regular student might not have known that these things are happening. म्हणजे सेकंड इयर स्टुडंट मागून आले आणि त्यांनी रेग्युलरिटी पण जॉईन केलेली आहे, पण रेग्युलर स्टुडंट्स आर नॉट आस्किंग मी एनी काइंड ऑफ क्वेश्चन ऑन माय व्हाट्सअप ग्रुप, ऑन माय व्हाट्सअप नंबर. Okay, so you can write down the doubts if you are having any in any of the points, and then it will get definitely get resolved. Now in the afternoon, we will conduct the practicals. Two practicals are remaining. One is for optical microscopy. The idea of all these things you are already known, you are already got, and last one is the that Brookfield viscometer demonstration. So that I can give onto the onto the video, so that that will get done by us in the afternoon. So any doubt? I told that you must come up with some doubts or the portion that may be remain uh, in our syllabus at any point of time. I might have missed, or anything that you need the repetition of a particular point, that you can tell me. Do you have the certain questions or topics that I have not covered or still remain to be covered? If still it is having, then you can tell me. By today itself only, I will finish up with all those things. Because जो ऑप्टिकल माइक्रोस्कोपी का जो प्रैक्टिकल है, इसमें कुछ खास नहीं है, एंड यू आर ऑलरेडी फैमिलियर विद दैट. और ब्रुकफील्ड का आपको मैं एग्जैक्टली डेमोन्स्ट्रेशन बता दूंगा कि क्या रहता है और वो कैसे ऑपरेशन करते हैं. तो दैट इट विल नॉट टेक टू मच टाइम, मे बी फॉर 30 to 45 minutes, एंड मीन टाइम में हम आपके डाउट सॉल्व कर सकते हैं. ओके और न्यूमेरिकल्स की बात. Am I audible now, everyone? हॅलो. या, तर मला हे सांगायचं होतं की कोणता डाऊट असेल तर मला विचारा. आज सगळे डाऊट रिझॉल्व्ह करू शकतो. दुसरी गोष्ट, न्यूमेरिकल्स. आय विल गिव्ह फ्यू न्यूमेरिकल्स विच मे बी बेस्ड ऑन ड्रग स्टॅबिलिटी. तर ते न्यूमेरिक्स आपण करूया, अँड दॅट मे सिमिलर टू दॅट विल डेफिनेटली गोइंग टू कम इन फायनल एक्झामिनेशन. ओके, अँड दुसऱ्याचे सगळे MCQs वगैरे रेडी करून ठेवा. अँड रेडी, आणि एक अजून गोष्ट सांगतो की MCQ विल डेफिनेटली गोइंग टू बी फ्रॉम द same portion that we have covered, similar portion that we have covered. Okay, so if you are having any doubt, you can place it onto the WhatsApp, then I will cover it. regarding lectures of revised lecture or extra lectures about the direct second year students. I am going to conduct the extra lectures of rheology, which was remaining earlier. One or two lecture I think we have covered, and remaining for remaining portion means for the rheology it is still needed to be conducted. So that I will definitely going to conduct tomorrow onwards. Within 2 days we will finish up with, means before 15 all the students will get finished up with all the revised lecture, extra lectures what has been remaining with them. Okay, and student strength is very low, 43 only. Okay, it is very alarming. Okay, be in touch with me, it would be beneficial for you. Okay, so with this we'll stop our lecture and later we will join in the afternoon. Okay, so thank you very much. Goodbye.